In this lesson, we'll be going over mixed circuits, which are also known as combination circuits, as they're a combination of both series and parallel circuits, meaning that we have to use every single one of Kirchhoff's laws as well as Ohm's law to solve them. After this video, you'll be able to solve pretty much any mixed circuit, no matter what values you're given. You'll be able to use each law to find what you're looking for to solve the circuit. Let's get right into our first mixed circuit. This one is pretty easy. As you can see, we are given the voltage of the battery as well as the resistances of each resistor. The first thing we should try to solve is the total resistance. To do that, we need to think outside of the box. Taking a look at this circuit, it looks like the first resistor is in series with these two resistors that are in parallel with each other. So in other words, we can say that R1 is in series with RA. And as we know, for a series circuit, total resistance equals the sum of all the resistances. So then how do we find RA? Well, we know that for solving resistance in a parallel circuit, it is the sum of the reciprocal of each resistance. So to solve for RA, it's 1 over RA equals 1 over 33 ohms plus 1 over 25 ohms. It should give you about 0.07 ohms, which equals 1 over RA. And then doing the reciprocal of both for 1 over 0.07, this gives us 14.2 ohms. And now to find RT, we add this 14.2 ohms to R1, which is 5 ohms. And rounding to two significant digits, we get 19 ohms for RT. Now that we have the total voltage as well as the total resistance, we can find the total current. And so IT equals 42 volts divided by 19 ohms, which equals 2.2 amps. Now, if you remember, for a series circuit, the total current equals the current at each resistor, but that's just for a series circuit. And if R1 is in series with RA, then that means IT equals I1, which equals IA, which all equal 2.2 amps. Now we can find the voltage at the first resistor. So V1 equals 2.2 amps times 5 ohms, giving us 11 volts. And since we know that in series circuits, the total voltage is equal to the sum of the voltage at each resistor, and that in a parallel circuit, the voltage is equal for both resistors. So following the path, R1 would first use up 11 volts, leaving the rest for R2 and R3. And so to show our work, we would put that V2 equals V3 equals the total voltage minus the voltage at the first resistor, which is 31 volts. And we can fill that in for V2 and V3. And now to find both of the currents of the two parallel resistors, we can do I2 equals 31 volts divided by 33 ohms equals 0.94 amps, and I3 equals 31 volts divided by 25 ohms to equal 1.2 amps. Just to confirm, we can add this 0.94 to 1.2, and it's just short of 2.2, but we know that we got it right since IA should equal 2.2. Let's move on to another one. Let's make it a bit harder too. Here we are given 4 resistors as well as the total current. When we look at the path of the circuit, we can see that it's first R1 and R2 in parallel with each other, which here again we can label as RA, as RA is in series with R3 and R4. Similar to the last question, we can solve for the total resistance. So first, solving for RA, 1 over RA equals 1 over 14 ohms plus 1 over 39 ohms. You should get 0.097 ohms equals 1 over RA. Taking the reciprocal of each, RA should equal 10.3 ohms. And to find RT, it equals 10.3 ohms plus 26 ohms plus 47 ohms to get a total of 83 ohms, rounding to two significant digits. The next thing that I wanted to point out is take a look how the current moves throughout the circuit. See, it first goes into this junction where there are these two resistors in parallel. The current splits up into each of these resistors but then meets back over here to form 24 amps again. And as we know, in a series circuit, the total current is equal to the current at each of the resistors. So that means IT equals IA equals I3 equals I4, which is 24 amps. So we can plug this in for I3 and I4, and all we need to find is I1 and I2. Next, I see we have both IT and RT, so we can find the total voltage. So VT equals 24 amps times 83 ohms, and rounding to two significant digits, it would actually be 2000 volts, but the correct way to show it would be 2.0 times 10 to the power of 3 volts. But for you guys, I'll write it as 2000 volts. Now next, a common mistake that a lot of people would make is they would think, oh, the wire's going to these parallel resistors, and according to voltage in a parallel circuit, they equal the voltage going in, no? So it should be 2000? Wrong. Because you're forgetting that R1 and R2, or RA, is in series with R3 and R4. So everything added up has 2000, not just VA for voltage. Meaning, the voltage for V1 and V2 should really be 2000 minus the voltage at R3 minus the voltage at R4. So first we'd actually have to find V3 and V4. Luckily we have both I3, I4 as well as R3 and R4. So V3 equals 24 amps times 26 ohms. That rounds to 620 volts. And V4 equals 24 amps times 47 ohms, which rounds to 1100 volts. So now, the total voltage minus V3 minus V4 equals VA, or V1 and V2, which equals 280 volts. And now finally we can figure out I1 and I2, which when added up together should be close to 24 amps. So I1 equals 280 volts times 14 ohms to give us 20 point amps. That's a good way to make it so that it has two significant digits and not just one by adding that decimal at the end. And then for I2, 280 volts divided by 39 ohms equals 7.2 amps. Now in total that's 27 amps, but we know that there was a bunch of rounding going on due to significant digits, but we know that we did everything right, and nothing seems to be abnormally wrong, so I'd say we're good on this one. Now let's go into the hardest of them all. Okay, let's analyze this. Once again, we are given the voltage as well as a total of 6 resistances. Taking a closer look, it looks like R2 and R3 are in parallel with each other, so we can label this RA. And it looks like also R4 and R5 are parallel, so we can label this RB. But what we can also notice is that RA and RB are parallel with each other, so we can call this RC. And now we can also see that R1 is in series with RC as well as R6. The hardest part of trying to solve a mixed circuit is trying to figure out the plan, figure out how you're going to execute it. Next, you always have to stay consistent with all of your calculations while also using every single rule to your advantage. So first, to solve for RA, we can do 1 over RA equals 1 over 21 ohms plus 1 over 46 ohms, which should equal 0.069 ohms equals 1 over RA. Then if we just find the reciprocal, RA should equal 14.4 ohms. Now for RB, 1 over RB equals 1 over 18 plus 1 over 16. We should get 0.118 ohms equals 1 over RB. And then doing the reciprocal, we should get 8.47 ohms. And now since RA and RB are parallel with each other, 1 over RC equals 1 over 14.4 ohms, which is RA, plus 1 over 8.47 ohms, which is RB. This should give us about 0.1875 ohms, which equals 1 over RC, and then we can do the reciprocal to find 5.3 ohms, And then finally, to find RT, we add 5.3 ohms plus 15 ohms to get 55 ohms for our total resistance. And now I wasn't kidding about this one being hard, and there's still so much to find. Luckily, we have the total voltage as well as now the total resistance, so we can find the total current. IT equals 150 volts divided by 55 ohms equals 2.7 amps. And looking at the circuit as if we're a series, IT should equal I1, which equals IC, which equals I6, which equals 2.7 amps. So we can fill that in for I1 and I6, but we still have to calculate each individual current for the 4 resistors in IC. Now that we have I1, I6, as well as R1 and R6, we can find V1 and V6. So V1 equals 2.7 amps times 15 ohms equals 41 volts, and V6 equals 2.7 amps times 35 ohms equals 95 volts. And similar to last question, we can subtract the two voltages for the resistors that are in series from the total voltage to find the voltages of all of the resistors that are in parallel, in which they all have equal voltage. And so to show this, we would put Vt minus V1 minus V6 equals Vc, which equals Va, which equals Vb, which equals V2, V3, V4, and V5 to equal 14 volts. And now all we have left is I2, 3, 4, and 5. And so I2 equals 14 volts divided by 21 ohms equals 0.67 amps. I3 equals 14 volts divided by 46 ohms equals 0.30 amps. I4 equals 14 volts divided by 18 ohms equals 0.78 amps. And I5 equals 14 volts divided by 16 ohms equals 0.88 amps. Now just to confirm, we can add them up, and it equals just under 2.7 amps, so we know that we did everything correctly. There's never a circuit that's unsolvable. You can always use what you were given to find for the unknown values, whether you use Ohm's law or any of the Kirchhoff's laws. Just make sure you use the correct significant digits, take everything one step at a time, and confirm that all of your work makes sense and adds up correctly. If you've made it this far into the video, chances are you're learning a lot and enjoy the content. So if you don't mind, consider subscribing, as it shows me that you like what you see, which helps me post more videos. Anyways, that's all for now. I hope you have a wonderful day.